Dear students, in this class we are going to discuss about the important functions of timer unit, and generally there will be only one difference between timer as well as counter. In timer always it need a kind of clock reference signal, where the counter always use some external sources which is originated from the outside of your peripheral devices. So let me check the important operation of a timer unit. So generally the match register, that is the data, what type of data we are going to store. Say for example, if I set number 5, so that is the number which is available in the match register. So the one side of the comparator which is having the original match register value, that is 5. Then there will be a timer counter register. So this counter register will be initiated or will be incremented by 1 based on the clock signal is coming from the prescaler unit. So here you can see this prescaler, and it will be activated based on the program clock. For every clock or every tick of clock, the counter register value will be incremented by 1. And so whenever the time counter register starts during the clock signal, and obviously there will be the matching process always takes place, and whenever the both values, so whatever the value which is available in the match register, and that value which is equal to time counter register value, so there will be some match occurs. So whenever match occurs, so immediately there will be a control signal will be activated. So this control signal may be in order to stop the clock signal, or when we want to reset. So based on the informations, the control circuit will be activated. So what are the functions of the register available in the timer unit? The first one is timer count register, that is TOTC. So actually this register size will be 32-bit. So this value will be incremented from 0 to the maximum value of FFF. So that is actually 16-bit and I mean 32-bit register value. So this is initialized by initially it is 0 for every tick of clock. That value, register value, will be incremented by 1. So initially it is all are 8 zeros, and for every tick of clock it will be incremented by 1. And the next register what we are having, timer control register. So count register value will be getting increased by the with respect to the clock signal. And the same way, the control register, this will be activated whenever there will be some matches occurs. Okay, so that's why the register size will be only 8-bit, and the lowest 2 bits only we are using for in order to generate the control signal. So we can see in the picture, so bit 0 as well as bit 1. So bit 0 it is enable bit, that is E. So this will be enabled enabled whenever the counter starts. And bit 1, that is reset. So during the if you want to initialize or initiate the next clock, so that's why this reset bit we are using. And the third register what we are having, match register. So the match register it is actually again 32-bit size, and actually the match register MR0 to MR3, that is match register 0 to match register 3. So totally 4 number of match registers we are using. So whenever the match occurs between the content or actual the loaded value with respect to timer counter value, and these 4 register values only verified. Okay, so during the timer operation, we know the timer count register starts to increment, and whenever match occurs, obviously these 4 bits are enabled. The next very important register we are having, match control register. So the control register size will be 16-bit. So whenever any event occurs, okay, so event occurs in the sense when the match occurs between the match register value as well as the timer counter value at that time, so there will be the event will be occurs. So the event, it may be either we want to start, or you want to stop, or you want to reset. Okay, so these things will be happen based on the matches occurs only. So for this purpose, this control register, the lowest 3 bits we are using in order to carry out the controlling operations. That is MR0, 1, 2, 3. And the next actually it is a clock, this pre-scaler. So it is actually only low frequency signal, and it will always generate the clock signal. There is a programmed clock, and this signal will be directly given to the count register. So then only the count register content will be incremented by 1 for every tick of clock. And very important thing about the interrupt mode in the timer unit. So the how the interrupts are going to be managed with respect to timer with the help of the VIC only. So that is vector interrupt controller. So we are having the vector interrupt controller only going to manage various number of interrupts access the time unit at the same time. So it has to manage, and it has to accept whatever the request coming from any peripheral devices. So based on the request level, based on the priority level, so it will generate the interrupt request message to the ARM processor. So the VIC vector interrupt controller, so this controller which receive various interrupts from the peripheral devices, and it has to analyze the interrupt nature. According to that only it has to generate this, or it has to forward your request to the ARM processor. So there will be some priority will be there. So among the number of interrupts, so based on the priority only, this VIC will generate the interrupt request message to the ARM processor. And certain features of VIC, it is actually 32-bit interrupt request will be initiated, and it has to accept, or it has to allow the maximum priority level 16. So obviously it will receive even though the 32 interrupt request will be received, and the 16 priority levels will be assigned. So based on the, again, interrupt nature only it is possible. So based on the software only it is possible to generate the interrupt request. Okay students, thank you.